definition language. So what is the purpose of data definition language?
Create tables, create attributes, create indexes, create the structure.
So creating data structure. So you model the database, the company database, your own database. Then that is just design. Okay, you need to build a house. So to build a house, you need the language because you need to order to computer database management system. So for that communication, we have database language. That is the SQL, structured query language. Structured query language mainly two groups. One is data definition language. It's a language for defining definition of your database, like the structure. So we can create a table, we can create the object, create the view, create whatever. That is building your database. So that is the data definition language. For example, we can create a table for each relation that you model in till the last class. Okay, for example, to create a table, to create employee, we can specify the list of columns. So another for each column, so we can create a table using the create table command in SQL. Then table name, then parentheses. At the end of each SQL, we should specify the semicolon that indicates the end of the SQL. In between the parentheses, we need to list of the column attribute that you model. For example, in this case, D name, D number, manager, SSM, and manager start date. So each column should have the name and data type. So data type in relational database model is much more flexible than other program languages. It includes the most general typical data types, including integer, float, double, character. In addition to that, we have variable character, one number, and date, time, and so you can use any of them for the data type. Also, these are the mandatory. In addition to that mandatory name and type, we should have the null. We can have the null or none. It's optional. So what is the modeling? Modeling. It's a group of concepts. It's a rule. It's a constraint. So in relational database model, there are several constraints, rules that you need to follow. Primary key, foreign key constraint, and check constraint, some other constraint. None is another constraint. So if this column has another constraint, you can specify it. Also, primary key can be specified when you create a table. And also unique for candidate key. It's not selected as a primary key, but almost the same as the key, so we can specify this one. Also foreign key. So we have learned such a way, many different ways to create a database. Okay, that is the database definition language. In addition to media, we have data manipulation language. What is the data manipulation language? It's a language for manipulating data. So data manipulation language, for example, you can insert the data, you can delete the data, you can update the data, and you can select the data. For what? Create the database object, like the table. Okay? So last week we learned about the mainly data definition language. This week we are going to learn the data manipulation language. How can we select the data? How can we update the data? How can we insert the data? Okay? One more thing. During the last exercise lab, some of you guys created the index, right? But we didn't cover the what is the index. What's the index, actually? Yes.
An index is like a catalog used to speed up search and sorting and.
So catalog is not the index. Catalog is a kind of the description. It's a set of description. But anyone has the textbook? Thank you. So, any textbook, when you have the textbook, so if professor asks to find the information about the materialized view. So I don't know anything about the materialized view, how can you find that information? If you know the title of this section, you can find it, but you don't know where it is. So at that time, you can go back.
The index or context.
End of the book, you can find some bibliography, that is a reference book, and also in this textbook has also index. What can you find from index? List of keyword as well as page number. Okay, since keywords are sorted by alphabetical order, you can find it easily. The location, the page number is exactly same thing, 100% same thing in database. So actually when you access the data without indexing, that is much slower than without using database. So it's not good for using database. Somebody said data using databases should be faster than without using database. Then how can we address that problem? Using index. So we can reorganize. In other words, we can sort the data by specific column. That is called the indexed column. So I'd like to access very fast using social security number. At that time, you can rearrange, order, sort your social security, your data, employee data by social security number. Then you can find very fast. How can you find? You can use a binary search if data is sorted, because the binary search requires
order, ascending order.
So log and order, right? Log based on 2, log n based on 2, right? It's much faster than the brute force way. You should learn this in your file structure course or algorithm course. If you forgot, why don't you review? It's very easy. So index is a sorted data. So if you create the table for primary key or unique key, automatically DBMS create the index for D number. In other words, we organize the department data by D number. And also, if you create the unique constraint, this data structure also reorganized by D name. Then, why DBMS automatically create the index when we create the primary key, when we create a table with a unique key? Why we need the index? What's the relationship primary key and index? Yes.
Because when we relate two relations with one relationship, the DBMS can conclude tuples from one relation into another relation. So it needs this index to search between the tuples between two entities.
Two entities? I don't think so. Any other? Why we need the index when we create a table with primary key or unique key? In other words, let me change the question. What is the primary key? What's the primary key?
It's unique.
Unique and not null. So in other words, when I insert the data, so this is a social security number, 1, 2, 3. If I insert the 3 again, can I do that?
No.
No. How do you know? It's an error or not?
Because
you need to check whether there exists a 3. Okay? So it's not unique. It's a violate primary key constraint. So if you have 1 million of data, then I insert a 3. You need to check 1 million data. It takes a long time. Okay? Instead, if you have sorted data, you can search here if there exists or not. So to check the constraint, you need sorted data. Sorted data means index. So automatically we need such an index. In addition to primary and unique constraint, index, I try to from time to time access very fast using super SSM, for example. But we do not have index for this one. There's no constraint. At that time, you can create explicitly. You can create separate external indexing structure for super SSM. That is indexing structure. So at the end of this semester, we are going to little bit discuss about the indexing structure used in relational database model. That is called B3 index, B plus 3 index. B plus 3 index is the most popular indexing structure used in 99.99 of relational database model. Okay, so we will, even though that is not part of database design, I'd like to have a little bit time because that is very important when you develop the database system after graduation. Okay, in practical things. Okay? So that is the data definition language. So there are many other ways to create them. Sometimes you can specify the cascade option, what default option, on delete, on update. So we already discussed. Then after you create the database, we can, let me a little bit jump to the select first. We will discuss about the update, delete, insert later after this. So we have database and data. Here, like the employee, whatever. The next thing is, we should know how to access such a data. That is called select from where? Well-known clauses. I think even though you do not have any experience on SQL database language, probably you heard about select from where. It's a very straightforward way. So for example, let's see this example. So query, I'd like to retrieve the birth date and address of employee whose name is John B. Smith. Okay? Which table do you need to access? Employees. Okay? So what information do you need? So birth date and address. So I'd like to select birth date, D-date, and address. From where? From employee. From employee. Be careful. Sometimes if you got such a unknown number, so one time I got the bill $1,000 a month. It's a maximum actually. So more than 1,000, it's kind of somebody take my there's a specific number for each cell phone. It's called there's a specific name. It's not your phone number. There's a specific. That is the identification. If you know that number, you can call from anywhere. So somebody steal my number, then call to Costa Rica and international call. So this is kind of such a call. From time to time, I got a phone call from Texas. So employee, from employee, okay? Then where? Condition. You can specify as condition. First name is John, middle name initial B, and last name is Smith. That's it. That is the SQL select. Very easy, very straightforward way. However, that's just part a little bit. I think less than 1% of SQL. Instead, we need to learn we need to investigate what is the basic of SQL today. So why don't you go back to the relational algebra? What is the relational algebra?
Relational algebra.
Shows what? Why do you need a relational algebra? Before that, before relational algebra, what did you learn? What is the title of this course? You don't know? Database? What?
Okay, design.
Design. So you design it, right?
Yes.
Then, what is the relational algebra then?
Well, relational algebra will help you design
Help a user
a user
to access the data. You design the data. You design, you model the database. Then relational algebra show how to access the data mathematically, formally. Okay? But we don't need such a formal way. Instead, we need a practical way. So, first go back to the relational algebra. Can you make the relational algebra for this query? Hey, why don't you try? So this is a query. It's not today's lecture. You do it already. Retrieve the birth date and address of the employee whose name is John B. Smith. Can you make a relational algebra for this?
Okay.
Yes, why don't you try? And the other, why don't you try? Using any scratch paper.
Page.
Okay? Almost, but and the comma, right? That is correct. This is a relational algebra for this query. Yeah. This is well-known format structure of the SQL. We select as.
Can I ask one question?
Yes.
Can we use not equal, less than, less or equal to in the conditions in the relational algebra? For example, if name not equal to John,
Oh, sure. You can use any
Like
condition.
this?
You can use any condition.
can you write the symbol of not equal?
Not equal John? Yes, you can use if that is your query.
Yes. Is it like this or this?
Or whatever. Because the relational algebra is the theoretical level. So as long as you understand, you can use any operation like this or this. Okay, it's not a big deal. Then, this is a well-known clauses. So select has a list of column, from has a list of table, and where has the condition. So, first, employee. Then, select this. Then, condition, this. That's it. It's exactly the same thing. So if you know the relational algebra, the making SQL is a straightforward way. There are several exceptions. You need to be careful. End of SQL should be
And
with semicolon. Okay, that is the indicator. This is the end of SQL. Okay, also for separator by attribute or call the table, you can use the comma, but not the end of attribute, not the end of table. Okay. Also case sensitive. The only case sensitive is the data itself. It can be select or capital letter. That's it. That is a SQL. Okay? What about the next example? Retrieve the name and address of all employees who works for research department. Let's do one more time for relational algebra. How can you make the relational algebra? Anyone? Any other volunteer? Okay, why don't you try? You can try. In your final exam, definitely I'm going to ask the relational algebra as well as the SQL. Okay? I'm not going to teach what is the syntax of Oracle SQL, Oracle SQL Plus. If you understand this, you can study by yourself. It doesn't take a time. It's not very hard. Okay? So I'm not going to teach the details of the Oracle SQL or the DB2 SQL. It's your job. Okay? Why don't you try and check your answer with him or mine? The first thing you need to understand what's the query said. Okay? Retrieve the name and address of all employees who work for the research department. Actually, we did in relational algebra. This one. Okay. Anyone else? Is it correct? So let's check together. So first, we need the name and address of all employees who works for research department. Unfortunately, we cannot get the research department information from company data with the employee. We need to access department. How can you access such a data? First department, research department. Then the number is a 5. Then find the match the annual from employee. Right? Then we can get employee information, which means we need to join two table, two relation. So this one is natural join. What is the natural join? In case column name is the same, the number, the annual is different. So you cannot use the natural join here. So that is the reason natural join is not popular.
Okay.
So instead you can use the join operation between employee and department, which means you need to have join condition. What is the condition?
DNO
T number is equal to T NO. So you don't need this one. This is a joint condition. Then, do you need to hold the data of joint employee and department? No. We need
Name and address.
who works for research department. So D name is equal to research department. So we have only research department employee and department. Then we need name and address. This is correct. The relational algebra. Then changing into how many relations? How many tables?
Two relations.
Two tables.
Two tables.
Department and employee. You can just copy. Employee, comma, department. You can use the comma to separate the list of tables. Then, in the select, you can use product. Copy F name, last name, and address. Then condition D name, research, and join condition. D number equal to D N. It's a straightforward way. So if you know the relational algebra, if you can make relational algebra, then the making SQL, creating SQL is just straightforward way. Okay, then there are they same or different? Let's say we have this. Are they same or different?
What are the same?
This one and the my SQL. Any difference? Who are same? It's the same?
It's the same.
Are you sure? From employee department. My answer is from department, comma, employee.
But should be the
So,
same.
number one, they are same. Number two, they are different. Number three, they are same and different. Number four, none of the answer. Which one? Number one, same. And number two, different. And number three, both of them. Why is it different?
You choose from the employee, then you keep the employee information. If the department in the front, then you keep the department information. I see.
Close, very close. Answer is it's the same. Number three, same as well as different. In terms of the output, okay, what is the output? Probably the five. Five, how many? 1, 2, 3, 4 employees. John Smith will be returned. Franklin Wong will be returned. And Namesh Narayan will be returned. Joyce English will be returned. Both of them. In terms of the output, my answer, my SQL is the same as the textbook. Okay? So, it's the same. However, it's the different in terms of what?
Speed.
Speed, performance. Okay? In other words, what he's saying is DBMS access the last table first. They cannot access at the same time. First, access employee information. Then, check the condition for each department. That is different from first access department check this for each employee. Think about extreme case. You have 10 millions of data, just one data. For employee, for department, you need to access 10 million time of employee, then check condition for one data. Versus you have one data for 10 millions of data. If this D number is sorted, indexed, you can find easily the matched data. Which one is faster?
Last.
Definitely, this one is much faster than this. So, who is in charge of this first? You guys know how it works. Also, Query Optimizer in DBMS software will decide which one is the optimized one. Sometimes they change, even though you use this one. Query Optimizer will replace the swap the position. Yeah? Because output is the same, nothing good, it's not risky. The problem is how fast. So in terms of the performance, it will be different. If you do not understand this, don't worry. It's not part of our class. It will be discussed in the advanced level database design, but you'd better know in real life system. So in terms of the output, they are same. So select has the list of attributes, from has list of the table, and where condition. Where condition has the condition as well as the join condition. One more thing. Everybody knows now, it's a join operation. So how many tables are joined in this case? Two tables. When you join two tables, how many join condition do you have? One, because we have one table, another table. You need to join. So how many link in between? One. You need to connect two with one join condition. So that is the reason we have one join condition. What about when you join three tables? How many join condition do you need? Two. Because you need to connect the first one, second and third. What about n number of tables? n minus 1. So that is most frequent mistakes. So sometimes your query has 10 tables, 15 tables in one query. You should have n minus 1 join condition. What happens if you miss 1 or 2 join condition?
The query won't work well. Won't give you
Error?
no,
No, it's not error.
but not specific, not correct information.
Not correct information. It takes a long time. Why? It will be Cartesian product without join. Can you remember that?
Yeah.
Cartesian product plus join condition is the join operation. No, not join condition, select operation. So if you omit such a select, it will be Cartesian product. It's all the combination. Sometimes it takes a long time. So be careful. So this is an example of join three different tables. So query is, so from now on, I'm not going to use the relational algebra because we learned a lot the relational algebra. We are going to directly discuss making the sequence. For every project located in Stafford, list the project number, controlling department number, and department manager last name, address, and birthday. Why don't you remember the query? Then we will go back to the company database. Then can you remember that? So for every project located in Stafford, then list project number, controlling department number, and the department manager last name, address, and birthday. So for each project, we need what? The employee information, right? So can we join? What is a common column? D and O is in employee. D number is in project. Can we join employee and project?
Work zone. Project number and TSS.
I'm asking project and for each project, okay? For each project, we need project number, project name, and supervisor, social security number, address, and birthday. So we can find most of information from here and employee. Then we have common column, D number and DNO. Can we join?
No.
Why?
Well, yes, we can.
We have to do it.
So we have two answers, yes and or no. Why we cannot?
we have to access. We have to join through the department.
Welcome.
We need to join through the department. Why? Why we cannot directly join to employee?
There's no thing.
No foreign key. No foreign key.
So no foreign key. Yes, correct answer. Actually, we do not have foreign key. D number, even though names are same, they are referring D number here. DNO in employee refer this one. It depends on course this one. So we need to join to department. Can you get it? So how many tables we need to access?
3.
3 tables. Project, department, and employees. Also, we need to access manager information. Can you remember the query? Query is managers. Last name, address, and birthday. Can you find the manager information from employee
No.
or the project? No, we do not. Only department has manager information. So we need to access 3 different. So do not take a look at only select part, projection part. Okay, when you decide which table you need to access. Good answer. It doesn't have foreign key. So not always, but SQL actually more flexible to join. You can join
them.
You can join them, but in this class, you can join through, if your model is perfect, you should have foreign key between them. So why don't you join through the foreign key? That's the basic. Then one more reason is manager. You cannot get the manager information from here. Okay? So we need to access 3 tables. Then how many join conditions do we need? 2. So let's see the answer whether we have 2. D number is equal to D number. Is a project. This is a department. Manager social security number is department. Social security number employee. So if you join directly employee and department, you may not get the same result. Okay? Then P location is Stafford. That is a condition. That's it. That is the query using joining operation. Then in this case, it's very hard to recognize which column is in the which table. For example, DNO. DNO, is it in the project or department? Definitely it's in the project. So to clarify the name of the table for each project, for each attribute, you can say project.
The table dot.
DNO equal department D number and manager's SSN is in the department. MGR SSN equal employee. SSN. Then it's much more clear than the without. Also, sometimes 2 tables have the same names of column. At that time, you should have the name of table. But the problem is I'm very lazy. I don't want project, department, even very hard to write. So, for convenience, we are not going to use the full name of the table. Instead, we can make the alias. In other words, nickname. How can we make the nickname? From close, from project, SP, comma, department, SD, employee, SE. Then we can say this is a P, and this is a D, this is a D, this is a E. Much more simpler and clear, right? Even I don't want S, so you can remove S part. It's okay. So which means project space P, comma, department space D, and employee space E. Then E dot, P dot, D dot. This is alias. Okay. One more interesting query is this one. What's the query? For each employee, retrieve the employee's name and the names of his or her immediate supervisor. Okay, one level of supervisor. How can you access? For each employee, John B. Smith, who is the supervisor? Who is the supervisor? 333-44555. As I request at the beginning of semester, bring your handout, chapter 7 and 8 handout throughout all the semester. So you should have that handout on your desk. Okay? Do not try to read. Definitely you cannot read the data. Okay? Anyway, so but probably you remember is the database. John B. Smith has a super SSN 333-44555. It's the next, Franklin 1. So how can the return might be John and Franklin, and so on. Franklin is the 888-66555 is the last one, James. How can you access such a data? First, access employee, then get the social security number, then find super SSN, supervisor SSN, then access employee again. How many tables do you access? Actually, 2. Even though they are the same, you need to access 2 times of employees. One is for employee. Another, next one is for supervisor. So, at that time, you can make the query employee. But, employee again. Definitely it's an error. We don't know which one is which. So you should rename S, E, S, S, comma. I'm very lazy to put S, you can remove this one. Also, they are the same. E and S together. Which means employee, employee S. Then you can specify E first name, E last name, S first name, S last name. What does E mean? This F name is for employee, like the John. And this F name is for supervisor of John. That is Franklin. Okay, then employee ES. E supervisor SSN is the same as the S social security number. Somebody may ask, how can I decide which one is E, which one is S? You decide. Okay? If you want an alias as the E1, E2, it doesn't matter. Okay, but you should know E1 is for employees information. E2 is for supervisors information. Next. What if? Where is not used? It's okay, not a problem. Without error, you can execute submit this query. Only select and from are mandatory clauses in SQL, where the others are optional. So it doesn't matter. There is no error. So which means it will return all the data of employee. Then here, what about the salary? Relational algebra. How many data will be returned? It will remove duplicate data. Can you remember that? It's not same as a social security number. Social security number is unique, so it will return all the data. It's actually same as the number of data. However, salary, if there is any duplicate data, it will be removed in relational algebra. What about in SQL? That is a different thing. SQL does not care. Okay? Duplicate data. It will return all the data as it is. Why? Yes.
Because it's part of a unique, it's joined with a unique value with SSN, which is a primary key.
Mm-hmm.
So it's every value in salary is an independent tuple.
No. My question is, why SQL does not care duplicate data? Duplicate data are not the relational algebra.
If you want, you can use distinct.
Yes, but it's a default. SQL return all the data as it is.
Yes.
Why? How can you find whether data is duplicated or not? What is the best way?
Join automatically.
We can make two queries. One of them is without distinct, one of them is with distinct.
So I have
And
such a
difference
card.
between them.
Card. I try to remove duplicated number from my card. How can you find the duplicate?
To give a wait condition.
No, just card. You need to sort the data. Okay? You need to sort from 1 to king, queen, whatever. Okay? Then, if there are any same number, take out. It's actually same thing. If we implement the relational algebra in SQL, whenever database return the data, DBMS sort the data, right? However, as you know, sorting is the most expensive algorithm and operation in computer science. Quick sort, something sort, still very expensive. So, what if we have 1 million of employees? It takes a long time, such a simple query. So, user cannot wait such a long response time. So, without sorting, in other words, without checking the duplication, it will return as it is. So be careful when you are using. Is there any other way to make the relational algebra? Yes, there is. That is called distinct. When you are using the distinct, it's the same as relational algebra. It will remove duplicate data. Are they same? No. They are not same in terms of the output. Also, in terms of performance, speed. This one is slower than this. Okay, why? To check the distinct, you need learn the sorting the data. It's a very, very, very expensive operation. It takes a long time. That is the difference between SQL and relational algebra. Also, sometimes I want to retrieve all the columns attribute. Yeah. Do I need to list all the things? No. I'm not such a diligent to write down everything. I never write down. Instead, you can use asterisk to indicate all attributes. What about join operation? Only employee, only department, both of them. All columns of employees as well as department will be returned with
Can we-
a service.
Can
Yes.
we make the accept operation like star minus
No.
accept?
It's not easy. We already discussed this thing. Then some set operation. We can use the set operation union, intersection, minus in SQL, just like the relational algebra. So, one thing you need to be careful when you are using the set operation union, intersection, minus is
Data type.
type comparability. Okay? That doesn't mean it's exactly same name. No, it doesn't have to. Sometimes different name. It can be P and it can be N and whatever. But data type should be not exactly same. It can be comparable. Comparable means if you can convert. Okay? But when you are learning, when you are studying this one, same data type. That's enough. Okay? Then one more thing is, so from this is one independent query. The return of the first one upper query is P1, P2. The second one, the lower query is P1, P3. What is the output of union in this case? P1, P2, P3, or P1, P2, P1, P3? Which one?
Relation.
First one, second one. First,
Is it
Second.
the relational algebra you mean?
no, sequence. In the sequence.
Second.
First.
That's if it is obvious, probably I didn't ask you. In this case, when you are using set operation, it does not allow duplicate data. So P1, P2, P3. It's not like the select. Okay? But if you want P1, P2, P1, P3, duplicate data, that time you can use all.